Packet pushers.
Hello, amazing human, and welcome to the Day 2 DevOps podcast, where the DevOps is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day one and beyond. Sadly, Kyler was not able to join me today, so I'll be hosting this one solo, but don't worry, I've got company. Today's guest is Jeff Baxter, VP of Product Marketing at NetApp, and we are going to have a fascinating conversation about something you might not think about too much, but maybe you should. That thing, storage. Without storage, you don't have anywhere to put your data. And without data, your company can't really function. Jeff and I are going to talk about the challenges of managing storage in the modern era of cloud and AI. We'll talk about cybersecurity, data gravity, and unified monitoring. It's going to be a hoot and holler. So sit back and enjoy our data stream of consciousness with Jeff Baxter, VP of Product Marketing at NetApp. Jeff, welcome to Day 2 DevOps. How you doing, man?
I'm good, Ned. Thanks. I'm looking forward to hooting and hollering with you.
Awesome. Can't wait. Let's start with a definition, because when we were doing some briefings and plannings for this, you brought up a term that I was unfamiliar with, which is data infrastructure. What is data infrastructure, and how is that different from just plain old infrastructure?
Yeah, so that's a great question. I think in your term, you talked about storage, right? I always laugh when I tell relatives that I'm in storage. They always think like, those public storage units, like I'm going to be on OnStars or whatever, right? And
Right.
it's like, oh no, let's define it. I've been doing storage now, enterprise storage for, 30 years or longer, right? And, I had a friend a long time ago who said, storing is boring, right? This concept of just storing data, it's like, yes, you have to do it. It's kind of like death and taxes, right? It's going to happen, right? You have to store your data. And especially in this era of AI, data is more and more important. But that's really the point, is it's less about storage and it's more about data and what is the infrastructure your data actually resides on. And we're not talking about the SSDs or the spinning disks underneath. Yes, those are important at some level, but about building a data infrastructure that spans all of the places your data lives, right? So edge, your data centers, cloud, multiple different clouds. And it's about thinking about your data infrastructure as much as you might think about your networking infrastructure or your compute infrastructure, right? Because it's really and increasingly a living, breathing thing that needs its own level of thought and care, both in planning and in operating, not just in, okay, I'm going to stick all my storage in one place and be done with it, especially in the era of AI.
When you put it that way, comparing it to compute infrastructure or network infrastructure, I start thinking about layers of abstraction, because I don't concern myself necessarily with the CPU or the cores on one single server somewhere, but I am thinking about pools of resources, a pool of compute where I can run things. And there's abstractions that help me interact with compute in that way. Something like virtualization or Kubernetes can help me take a bunch of resources and pull them together. Is that the same idea that you're applying to storage and data in this case?
Yeah, it's exactly the right idea. So what NetApp tries to do, and we call ourselves, and I'll just do the tagline to get out of the way, right? We call ourselves the Intelligent Data Infrastructure Company. And we could talk more about what the intelligent means a little bit later on. But when we think about data infrastructure, it really is that sort of abstraction layer, right? So you're going to have storage everywhere. What our approach is, similar to what VMware or any of the various hypervisors have done over time, is to abstract that up. We have our operating system, which is called ONTAP, that runs on all different types of on-prem storage, as well as in all of the major different clouds. And so our goal is to really abstract it up into, we literally even call them storage virtual machines, right? So the idea is you're not thinking as much about your physical infrastructure. There certainly is someone on, to use your parlance, on day zero or day one, thinking about racking and stacking and setting up, just as someone's doing with compute nodes, right? Or in the cloud instantiating that first instance. But everything after that is automation and API driven, and thinking about it at an abstracted level so that you're thinking about your workloads, what data they need, what service level objectives you need for them, and not so much about the underlying physical assets, but about a data infrastructure that spans everything. And how does that interact with, your AI data workflows, your DevOps workflows? If I need to stand up a new Kubernetes cluster, I don't want to be thinking about storage. I just want to think about what service class do I need? Is it persistent? How much performance do I need? How many instantiations do I need? And have my data infrastructure ready, automated, and standardized so that I can just deploy on demand against it.
Right, right. Hey, we're not talking about platters anymore. We're not talking about cylinders. We've moved well beyond that.
I mean, maybe.
Maybe. You mentioned intelligent is part of the tagline, intelligent data infrastructure. How does intelligence apply to this data infrastructure we're building out?
So I think of it as, you hear about smart power grids and everything, right? So the concept of having power everywhere is one thing, and having a data infrastructure everywhere is one thing. And I think although it's still conceptually something that people are trying to build out, I think the idea of having a data infrastructure is straightforward. But if you get that data infrastructure standardized, if you build it all out, that's great, but it doesn't offer any benefits in and of itself. It's when you start to add intelligence into it, right? When you start to be able to perform operations on it, whether it's simple or basic as automation or unified control of all of your data or unified observability across all of your data, that's at least sort of a baseline. And then adding on additional services to make it more efficient, make it more sustainable, to build governance directly into your data infrastructure, to build cyber resilience directly into your data infrastructure. These are all sort of the data services that we build on top of a data infrastructure that we consider making it intelligent. So just like a power grid, its basic function is to serve power, right? But there's far more that a power grid can do to be smart balancing, take advantage of the right clean energy, and all these other things that smart power grids do. Same thing with driving versus, smart driving or autonomous driving. It's the idea is how do we create a autonomous managing data infrastructure that can apply all these intelligent data services to add value on top of it. And that's what we mean by intelligent data infrastructure.
I like the power grid analogy because that's something that I've been kind of doing some research on recently anyway. And so it really kind of clicked in my head a little bit. I'm going to be a little bit of a devil's advocate here. Every public cloud has a native storage service already.
Yes.
Why would I not just consume those native storage services on all the different public clouds?
Yeah. To be fair, I think almost every one of our cloud customers does, as well as use ours, right?
Okay.
It's a matter of choice and it's a matter of standardization. And I think a lot of our customers may start with the native cloud services and it may work for some basic applications. There is a benefit to NetApp doing 30 years worth of storage and focused on data infrastructure, right? And so we generally find that we're higher performing, potentially more resilient, more feature rich than some of the native cloud storage offerings. And that's why, to be frank, all three of these major cloud providers partnered with us. They don't need to. I mean, let's just be honest. Look at their size. No one's kidding themselves there, right? And so if they didn't think there was a need, there's no reason they would have reached out to NetApp. And I think the important part for us and what really distinguishes us is our offerings on all these major public clouds are not actually our offerings, right? So on Amazon, there's Amazon FSx for NetApp ONTAP. That is an Amazon first party offering, right? It's not even in the marketplace. It's literally their offering. On Microsoft, Azure NetApp Files is a Microsoft offering. On Google Cloud NetApp Volumes is a Google offering, right? So they actually reached out to us to OEM our technology and essentially build it directly into their cloud so they could get advantage of all those data management. So there's clearly something there because none of those cloud providers are going to do that just for fun.
Right.
And they haven't done it with anyone other than NetApp, which I think tells you something else interesting about NetApp in terms of just the underlying technology. And then the other reason for our customers is that it's fine if you're just on a single cloud. Like if you're on Amazon and you want an S3 instance, choose AWS S3. It's a no-brainer, right? If you're just on Amazon and you want some basic file services, you're going to choose EFS. That's fine. But when you want advanced data management, or more importantly, when you're on multiple clouds, as the vast majority of our customers are, right? The benefits of standardizing start to become sizable as opposed to having to think about how do I not just store my data, but how do I manage it? How do I maintain security, compliance? How do I back it up? How do I do all of these things and have it be different on-prem than a different modality in AWS, a different modality in Azure, and a different modality in Google? It starts to become painful, hard to automate, and hard to ensure compliance. And that's where the benefits of being able to standardize on an intelligent data infrastructure across all of it really start to shine.
To take it back to the compute example, having the ability to run, say, Kubernetes across all three different clouds lets you interact with each of them in a fairly consistent way. There might be slight differences in their implementations, but if you want to, you can run your own Kubernetes clusters in all these clouds, and then it can be exactly the same. And that's almost what you're talking about here. I knew about Azure NetApp files, and I've used it before, but I was unaware that you'd actually reached out through AWS and Google Cloud and now have that same offering on both of those clouds as well. That's wild.
Yeah, it's amazing. And yeah, it's been a journey. NetApp first put its software on the cloud about 10 years ago. I remember sitting at our user conference and we were showing it off in 2014. I think we had the first usable instantiation of 2015. It's been a little while, so if I got the dates a little wrong, forgive me. But I believe that's about right. And that was just putting our software as a basic, just like almost software appliance running on AWS, right? And then 5 years ago, Microsoft came to us and said, hey, we really want to do Azure NetApp Files. And then we followed that with AWS FSx. And then most recently, in the past year or so, was Google Cloud NetApp Volumes, right? So it's just been this constant drumbeat of clouds coming to us and asking us to put our software on those clouds. And then what I think is cool is we have that option, which really is the as a service sort of offering where it's being run by Microsoft or Amazon or Google. And then we also have the ability to run in the marketplace as just a full instantiation of ONTAP. So it's almost just like your Kubernetes example, right? You can have a managed service offering where you get sort of the Microsoft version of NetApp ONTAP or the Amazon version. And then you can actually just have a physical box where you just pluck the software off and run it, where you're running as root, you're the admin, you can set it up however you want. And you have both those options, right? Which is just the amazing power. So you can choose, in your example, to run a managed Kubernetes service, or you can just stand up your own Kubernetes cluster, but it's all the same. Like the APIs are all the same, the command layer is all the same. That is really what the magic is. That's the secret sauce.
The fact that it's the same consistent API, so it's going to be the same software and tools and packages that you use to manage your storage and also monitor and interact with it is just going to be consistent across all these different clouds. In my mind, I was thinking, okay, if you're already a NetApp customer on-prem, then this makes a lot of sense to then use it in one of the clouds. But now that the way you're phrasing it, if I'm across three different clouds, that's three different storage services I got to interact with, three different things to monitor, three different ways to control things, unless I have a unified storage solution or intelligent data infrastructure that just gives me that consistent interface across all three. That's huge, even if I don't have NetApp on-prem already.
Yeah. And a huge number of our cloud customers are actually new to NetApp customers.
Hmm.
So that's the interesting thing. Yes, if you're using NetApp on premises, I don't think there's any reason why you wouldn't use NetApp in the cloud. It just makes life a lot easier. But so many of our customers are coming in actually through the cloud, first using it not because they feel like they have to or to connect to their on-prem data centers, but because when they actually kick the tires on it and they look at the performance and look at the data management features, it's the best file system available for them, regardless of where it came from. And then certainly if they're across multiple different clouds, it makes things so much easier. What I would say to customers is, even if you don't want to look at NetApp, and I don't want this to be like a NetApp sales pitch or anything like that, thinking about building out a standardized data infrastructure, however you do it, is critically important, right? Because the amount of data and the growth of data and the importance of data is only going to increase. And this whole AI wave, I was talking to a customer and they said one of their biggest problems is not just that the amount of data is growing, but in the past they were allowed to throw away data, right? And now the idea is every piece of data they create is possibly a work product that could be used to feed a Gen AI engine, right? And so now they're terrified of throwing away data. And that growth is just unsustainable if you're doing it in an ad hoc manner. If you're just creating volumes all over the place and throwing things around, then when you come back and try and figure out what am I going to use to feed an AI data pipeline, unless you've thought about that with rigor ahead of time and built compliance and built governance into place and built structure into place, it just makes life so difficult, right? When your data scientists come to you and say, take me to your leader, point me to your data, it's like, where am I going? Left, right, sideways. Whereas if you have this data infrastructure in place and you built intelligence into it, it makes you a hero, right? It makes you that person who can directly unlock the value of your company's data to all these data scientists that are going to be flowing towards it.
Jeff, I have an attic in my house,
Mm-hmm.
and that attic is full of things.
Yes.
And when I need to put something somewhere, it goes in the attic.
Yes.
What you're talking about in terms of the AI example, I do not have a well organized and streamlined and categorized data pipeline. I have an attic full of stuff.
Yes.
And I don't know what to do with any of it.
Yep.
So can NetApp come over to my house and organize my attic for me?
I mean, I'm not sure directly, but on the analogy side, yes. Actually, the funny story is I actually have a home organizing person that I pay to come in because my place is just as bad. I moved fairly recently and everything like that, and trying to get that done, it's just hard, right? It's a mindset that I don't personally have. And I have this person who comes in and it's just like organizing everything. Everything gets labeled, everything gets put in the right place. We decide what we need to keep, what we don't need to keep. And that, it's a good analogy. That's exactly what NetApp helps our customers do from a data infrastructure perspective, right? If you think about that, right? Rather than having data scattered in, pods someplace else, right? Some stuff in the attic, some stuff in the basement. Everything is labeled, everything is put in the right place. We help customers take advantage of where the right place is. We have tools that will help customers say, hey, this data makes a lot more sense up in the cloud. Or, hey, you've got this data running in the cloud on the highest service level. You're paying a ridiculous amount of money for data that's not being used. Let's stick it in the data center on hard drives, right? We joked about platters and cylinders being out earlier, but hard drives are still around. They're still the cheapest form of media. If you're never touching that data anymore, let's tear it down there seamlessly and automatically, still have it be available in the cloud if you need it, but transparently move that data down on-prem so that you have the lowest possible cost, and vice versa, right? Those are the sort of data services. It's almost like having that person come in and do your home organization for you, except instead of bringing professional services to do it, and certainly there's part of it, we do it with algorithms, right? We do it with everything and all the tools that are built into this intelligent data infrastructure so that it will, sort out your storage for you and recommend where to put things and automate that placement of things, just like VMware did a decade ago or longer, 2 decades ago, with virtual machines and saying, hey, you should move it to this host. And hey, we thought about doing this. Hey, you need more memory here. We can do the same sort of thing on a data infrastructure level.
Right, right. Sort of DRS for your data.
Yeah, exactly. Exactly right.
I want to shift the conversation a little bit to some other data management features, because one thing that I know people are very concerned about right now, and you can't go a week without seeing it in the newspaper or in an RSS feed, is ransomware. And I'm just curious, what does NetApp have to offer around protection from ransomware? Because I know that's top of mind for a lot of people.
Yeah, it is. I mean, on a daily basis, we talk with customers about it. And I think that there's a couple of different things I'll say. First, knowledge is power. So knowing where all your data is and having it in this intelligent data infrastructure so that you have access to it. You've run governance, you've run compliance. One of the things we've done in the last year is turn on a governance and compliance option for all of our customers. So if you have your data in NetApp systems, you can automatically be scanning it for PII data. You can automatically be scanning it for confidential data. You can automatically be looking at the access permissions of it, right? So the idea is get down to least necessary permissions on the least amount of PII or other confidential data that you need to have, right?
Mm.
So a lot of these leaks some are just full scale penetrations, right? And we deal with that in a different way, but others are just data that's exposed that never should have been exposed, with social security numbers or credit cards that never should have existed, right? And so step one is sort of hygiene of your data, right? And making sure everything's in the right place and with the right security levels. Step two is really moving into sort of a NIST framework of, protect, detect, and respond. We operate on a zero trust model where we assume that we're going to constantly get attacked by ransomware. We assume that our customers have endpoint protection in place. They have all the other sort of things that we don't do, right? We don't try to be all things to all people. But we used to, a decade or more ago, assume that, okay, we were encased in this fortress, right? And that if something got down to the storage, it was catastrophic. Now we just operate under the assumption that everyone's network is constantly penetrated, because it probably is, right? Let's be honest, right? If you're any sort of large scale enterprise, the chances that at any given time you have someone within your network who probably shouldn't be there are pretty high.
Mm-hmm.
And it's a sad fact of life. So then we have to operate on the assumption that we have to be able to detect attacks in real time and be able to respond to them in real time. So one of the things NetApp did is actually build anti-ransomware technology directly into ONTAP, directly into our enterprise storage software, which traditionally has been more of a perimeter sort of security thing. Now we're looking at it saying, we actually own your data. We see all the metadata coming through. We can actually notice in real time if something's happening and alert you in real time if there's a ransomware attack. So that's one of the innovations we brought to the industry over the last 2 years. Is we're basically one of the first to actually embed anti-ransomware technology directly into the data storage layer.
Okay. So it's not running at some monitoring layer above it. It's actually being analyzed at the operating system layer.
Yeah, we're getting your writes anyways, right? We have to store your writes. And we're doing all sorts of things like deduplication and compression and compaction, all these other data operations on it. We have to track all the metadata on it anyways. Shouldn't we notice if all of a sudden your write stream changes dramatically and everything's coming in encrypted and our dedupe percentage goes from 80% down to 0% because it's all unique blocks, right?
Oh, yeah.
If your amount of writes goes from a trickle of a couple KB a second up to megabytes or gigabytes per second, odd, right? We have all these flags, right? That if we just thought about and if we build some sort of basic algorithmic detection, we could detect it. And that's sure enough what we've done, right? We've been able to go ahead and capture those signals. The other thing that we just made generally available just in the last week or so was actually building AI ML directly into that model. So the first models were more based upon entropy, file signals, different things like that. We've actually built an AI ML model in now that can learn and adapt to basically these attacks as they're happening. We know that attacks are being generated more and more with AI, right?
Right.
And so we know that, it's the old Terminator joke, right? The only way to fight AI is probably with AI. And so we're trying to use AI for good. And so what we actually do is we're constantly getting new malware feeds from other secure vendors. We're constantly infecting our own clean data sets of files. and using that to train machine language models on, and then go ahead and push those back into our customer systems. And so we went out and had, for example, SE Labs test that, and we found we had over 99% accuracy at detecting malware that we hadn't been exposed to and zero false positives. And that was really the benefit of the machine learning model. The earlier model had pretty high accuracy. It was still in the high 90s, but it had too many false positives for us, right? Because it was just going on entropy signals and other things like that. So if something new happened, it didn't have any really way of thinking to understand if that new might be anomalous. So it always flagged on it. The AML model is able to learn a little bit more, so it doesn't get fooled by just regular behaviors that may seem a little bit off. So that's actually been a big improvement, and that's something we've now made available to all of our customers.
Yeah, that false positive thing is such a problem because it usually leads to people turning the feature off.
Yeah, they turn the feature off or it becomes noise, they filter it, right?
Exactly.
And we actually, one of the things we showed off at our user conference was now building this feature to integrate into security dashboards, right? So going into Splunk, going into the AWS Security Hub, because the idea is you probably have a security operations center if you're a larger enterprise, right? You probably have 24/7 monitoring. You can't wait for a storage admin who might be asleep at 2 a.m. to sit there and wake up and 10 hours later respond to a ransomware attack, right?
Right.
It's got to go to a security operations center who can immediately take automated response actions to block that access, to restore back to backups and everything far in advance of any regular, it's got to be a 24/7 operation basically today.
What does the response look like on the NetApp side if ransomware attack is detected? Is there an initial response and then a recovery?
The first thing we do is we send the alerts, however you have that configured, and then we instantaneously take snapshots, so point in time snapshots of the data. Because the idea is if we can detect that data, that attack within the first percentage of your system, right? So think of it as like the tip of the iceberg, right?
Mhm.
What we don't do is stop IO because in the event we have made a mistake, we don't want to create an outage situation, right? That'd be a good way to get your feature turned off. I can guarantee you that, right? The first time you have an outage because oops, we thought it was ransomware, but it turned out Timmy was just dumping all his MP3s onto his share, right? But we do take this instantaneous snapshot. So the idea is we'll alert. You can go check what the attack is and shut off whatever's going on. So we have integration into parts of our stack that also do user behavior analysis. So you can see based upon the signature something's going on. Then you can go in and see, okay, well, John just encrypted 6,000 files and deleted another 18,000. I'm guessing that's probably our problem, right? And
Yeah.
either John is being a really poor insider attack or has compromised credentials, right? And so you can lock him out, figure out what the issue was. But in the meantime, we've taken this point in time snapshot. So for, say we take snapshots every hour, and this attack happens 55 minutes into that hour, right? For that 1% of data, you roll back to 55 minutes ago. So you lose 55 minutes worth of data.
Okay.
For the 99% of the rest of your data, since you took a snapshot right at the time of the attack, you lose nothing, right? So you roll back to that snapshot from 5 minutes ago, and everything that's happened after that is all your files being encrypted. So it's all garbage, right? So you roll back, and we actually have automated orchestrated ransomware protection that workload by workload will go through and analyze. This is the point where the attack happened on this workload. We'll roll you back to this snapshot. That rollback happens in a matter of seconds. So you can be back up and running in minutes to hours. And we see these ransomware attacks take companies down for weeks, right?
Yeah.
Now, obviously, if it's some massive attack, do I think everything's going to be up and hunky-dory 30 minutes later? No. We know there's forensics. We know there's all those other things. But our goal is if you have alternative infrastructure, if you have an alternative data source, even if you need to clean room this other infrastructure to see what's going on, you can actually restore to that in a matter of hours to the secondary infrastructure and be up and running on a DR site or other things in a matter of minutes, right? And so that's what we're really trying to do is allow our customers to know that ransomware is a reality. Any vendor that tells you we're going to protect you and make sure that ransomware never hits you is lying to you, right? That's unobtainium, right?
Right.
It's just like saying your personal computer is never going to be affected by security issues, whatever, right? But we want to minimize the attack surface. We want to secure it as much as possible. And then we want to have this rapid response in place so that when you do get attacked by ransomware, it's a bad day, but not a horrific month. That's the goal.
Yeah, I have worked on some consulting engagements where ransomware was involved and took down businesses for weeks. And the recovery process was incredibly painful. One, we might have lost everything if they hadn't luckily had some S3 buckets with backups
Yeah.
that the person had lost their credentials for.
Oh, geez.
And so it was just luck of the draw that that S3 bucket existed and we could find and later mint credentials for it. But the ransomware attack couldn't get to it because there were no current valid credentials. Just like absolute luck.
That's an inadvertent cyber vault, right? Is I think what we call that.
Exactly.
We have customers who are keeping third or fourth copies of their data now in logically air-gapped cyber vaults. Actually, we have a reference architecture we built for it. And we have a lot of customers using like disk drive-based systems or whatever as a cyber vault that they will never, ever run on. But they actually have their primary storage teams don't even have access rights to the cyber vault, right? Whole different team holding the keys to it, right? And that way, any of the credentials that could erase or destroy your primary storage system can't touch the cyber vault. So in the event of a complete disaster, it's the same sort of thing you talked about with the S3 bucket, except by accident, it's actually being designed purposely as a cyber vault.
Right. Wow, that's really cool. It is 2024, and I don't think we can possibly have a conversation without bringing up AI.
Ah, yes. Yeah.
Yeah. So, how is intelligent data infrastructure helping AI? Is it helping with training the models? Is it using AI? Probably a little bit of both.
Yeah, it's a little bit of both. So we certainly use AI and AI ops embedded into intelligent data infrastructure to optimize it, right? I gave you the example of fighting ransomware, right? But there's a million other examples, tiering, optimizing performance, all the other things like that. And then in terms of feeding this AI data pipeline, right? That's really where you need an intelligent data infrastructure where your data is optimized, it's available, it's organized, it's classified so that it can be used to fed AI data pipelines. And then I think there's a lot of focus on training LLMs, right? The reality is, yes, there's SLMs, right? So small language models that individual companies are training. And then you have these massive, huge companies training these massive LLMs, but there's probably less than 10 of those in the world. And the amount of GPUs you need to train some of these models is just ridiculous. And to have that sort of high parameter count LLM. And so most people are just going to use those models. And so what I think is more interesting is this recognition that okay, training is cool, but what's more important is fine tuning and inferencing and retrieval augmented generation, right? Because that's what the vast majority of us are going to do. The vast majority of people probably listening to this podcast are not going to be going out and building the next OpenAI model. If you are, cool, really awesome. I'm happy for you because you've got an awesome job. But the vast majority of us are going to be taking one of these models and saying, okay, how do I get my private data without feeding it into that model? How do I fine tune it? Or how do I do something like retrieval augmented generation so I can automatically create vector embeddings on the fly and add that in so that I get relevant responses to my business? And I think that's really where intelligent data infrastructure comes in, is building. We have these Gen AI toolkits that plug directly into ONTAP wherever it is across all of it and can automatically allow you to use, something like a Google Vertex AI or Amazon Bedrock or any of these different tools and directly train upon your data either in that cloud or elsewhere, but it still sees it as part of that cloud and use it to generate business contextual responses. That makes sense.
Yeah, that does make sense. And to go back to what you're talking about earlier, the labeling and the categorization of your data to effectively know what to do that training on or that retrieval augmented generation, you need to know where that
Yeah.
exists, where that lives.
Yeah.
And then send your process off to fetch it. So that seems like that's a big portion of it as well, is just categorization and labeling.
It's a huge portion of it. One of the things that I was really excited about that we unveiled at our NetApp Insight user conference here just a week ago when we're doing this, but it was in late September. We unveiled sort of our vision for AI moving into the future. And a big part of that was being able to build a comprehensive metadata catalog across all of your data wherever it's scattered, right? So the idea of moving all of your data into one central data lake is pretty much dead, right? Data is being written so quickly. It's in so many different places. This idea of I'm going to build a data warehouse and I'm going to use old ETL methods to move everything in there. It's not going to keep pace, right? It's just not going to work. So the idea is you've got to keep your data where it is, but build a metadata-based namespace that makes it look like you have a centralized data set that can allow all of your tools to get access to that data without actually having to pull the data into a central location. So that's the main thing we shared, was building out this global metadata namespace and then being able to build data collections on top of it. So imagine being able to go in and use natural language queries or whatever else you want to say, give me a list of all of the data in all of my different data sets that matches these different parameters and now dynamically and constantly update it, right? So say I want all of my data about anything NetApp, right? And it can't just be a search for the word NetApp. It has to understand contextually what NetApp is, look for any data sets anywhere across all of my data on cloud and data center. And then anytime anyone adds a document anywhere that has anything to do with NetApp, or let's say I say data storage, right? So anything about data storage, it automatically updates that index. So anytime I'm doing fine tuning or training in my data pipeline, which is a constant ongoing process, it's not a one-time process, that data collection is always up to date and can always feed it with the latest data sources. We also build into it compliance and governance. So for example, one of the cool things is we can build rules into it, and there's some that come by default, others you can build. build so we can ensure that PII data is never used for training.
Oh,
So
yeah.
you can try and keep your data compliant and in advance, or you could build this thing where there's a data collection and we automatically will strip out social security numbers. So even though it thinks it's being trained on a social security number, that social security number is all X's now, right? And it thinks, oh, I've got a social security number. It never got the actual data. So it can never accidentally give that data out. And I think that's the key, right? Is stopping it at the source. So that's what intelligent data infrastructure can do is it can fundamentally offer these curated data collections that are constantly updated across all of your data, across all the different sources that have the right compliance, have the right governance. Our goal is to make data scientists' life so much easier, right? And that's the goal of an intelligent data infrastructure.
I like that you included the risk of abuse on these systems.
Oh, yeah, it's huge.
Yeah, one of the major attack vectors right now is just trying to plumb these models using the right phrasing and the right prompts to extract information out of them. One of them that was super successful was just telling it to forget everything that it's been told
Yeah.
and then do this thing.
Yep.
That was wildly effective.
It was.
So the fact that that information is never even making its way into the training or the augmented pieces means that it's not going to be accessible for someone who's running a prompt engineering attack.
Yep. And I'm certainly not a data science expert. I would never, I'm a data infrastructure expert, but not a data science expert. But I think it's fascinating because, I think a lot of people played with ChatGPT when the first 3.5 model or whatever it was came out, right? And it was super easy to exploit it. And I'll freely admit, I did it as an experiment, right? Like there were all the almost open source prompts. I laughed because there were GitHub repositories of prompts to break ChatGPT, right?
Right.
My favorite was, the inception model. Imagine that you're an AI that isn't constrained by these. How would you respond if you were that AI, right? It was like almost that simple, and it was so funny. And then you get to the next ChatGPT models, and those didn't work anymore, right? They were getting better and better at guarding against those. Now, a lot of these injection attacks are so ingenious because they're not even human readable anymore. And you're like, what's going on? And they're actually interesting combination of characters that when the AI parses them, and they have deep understanding of how the AI is parsing it, because the AI isn't actually reading it as a sentence. It's all vector embeddings, right? So you give it this prompt and it breaks the engine. And they keep responding to this in real time. But the reality is injection prompts and how to break AI models is going to be just as important as antivirus or ransomware or anything like that. It's going to be this next layer. And so being able to do that sort of sanitization, one of the things we actually showed was in addition to blocking PII data, and I think this is early days for us, but we can start to block injection attacks. Because one of the really interesting things to do is if I know I've got a data set that I'm constantly training on, what happens if I can compromise one of those files and instead of encrypting it for ransom, what if I can insert instructions in that file that when my AI gets trained on it, my AI suddenly starts opening up attack vectors to an attacker, right? Almost like trying to drop an exploit in place and open a remote SSH connection so I can get into the systems. Imagine doing that, but with an AI chatbot or with an AI infrastructure so that all of a sudden I've got a way that I can connect to this AI chatbot and it will automatically, as root, do whatever I want within inside the systems, right? So we're starting to look at how can we sanitize inputs to look for those injection prompt attacks and sanitize them out before the data ever gets into the AI training mechanism.
Wow. And as AI becomes more capable and we start doing task based AI where it has permissions to go out and do automated tasks on our behalf, that's going to become even more important.
Just imagine instead of actually going on and encrypting all the files, you tell an AI to go encrypt all your files. So the AI does the ransomware for you. It's like, yeah. And then I want you to collect the ransom and send it to this PayPal account, right? Like, I mean, you can imagine, and I'm joking, but I can guarantee you it's going to happen pretty soon where people are actually using companies' own AI against them, right? And that's the sort of thing that if we're starting from this completely disorganized, all my storage is thrown somewhere in the attic sort of approach, right? We're completely helpless to respond to some of these advanced attacks.
Well, Jeff, this has been a fascinating conversation about all the things that the intelligent data infrastructure is bringing. If people want to know more, want to get some more information, maybe watch some videos, where's the best place for them to go?
I think the obvious one is netapp.com. If you go there, if you type, intelligent data infrastructure into your favorite search engine, I think you'll be kind of led there. And we can kind of walk through people what we build for them. The other thing is it'll give you a link into, we have this unified hybrid control plan we call NetApp Blue XP. You can actually just go in and start playing with it, right? And building out your hybrid intelligent data infrastructure. There's obviously free trials of the different software on the different cloud providers that you can try out and just start building out what a data infrastructure looks like to you. And then obviously, people can feel free to reach out to us and talk to us about what we can do for their company if they're interested in learning more. But I think especially for a lot of your listeners, right, just getting your hands dirty with it and diving into it and playing a little bit with the tools out there, that's all available for them.
Yeah, absolutely. Well, Jeff Baxter, thank you so much for being a guest today on Day 2 DevOps.
Well, thank you, Ned. I appreciate it.
And to you, dear listener, virtual high fives for tuning in. If you have suggestions for future shows, we would love to hear about them. You can find us on LinkedIn, just search for the podcast, or use the feedback form at packetpushers.net/FU. The FU is for follow up. You can find me, Ned Bellavance, over at nedinthecloud.com, and my amazing co host, Kyler Middleton, blogging over on Substack at Let's Do DevOps. We're both active on LinkedIn, so stop by, say hi. Did you know that you don't have to scream into the technology void alone? The Packet Pushers Podcast Network has a free Slack group that's open to everyone. Visit packetpushers.net/Slack and join. It's a marketing-free zone for engineers to chat, compare notes, tell war stories, and solve problems together. packetpushers.net/Slack. Until next time, just remember that doing DevOps is awesome, and so are you.